So students, we start with our topic on speed and velocity, right? Now let us discuss what is speed. Very often you calculate the speed. Let's say if you are an athlete, you calculate the speed that you covered in a 100-meter race, for example. So speed basically tells you about how fast or how slow, right? Maybe a person is running or a vehicle is moving, whatever, right? So speed basically tells you how fast or how slow a particular distance has been covered. Now, how do we define speed? What is the definition of speed? Speed is defined as the distance covered by a body in unit time. In unit time means per second. So speed is defined as the distance covered or travelled by a body in unit time. Speed can be calculated by dividing the total distance covered by the total time taken to cover that particular distance. For example, you have participated in a 100-meter track event or running race, right? Now you have covered that 100 meters, right? Let us say in 50 seconds. So the distance covered, total distance covered is 100 meter divided by the total time taken for you to cover that distance. Let's say I told you, let us take it as 50 seconds. So 100 meters divided by 50 seconds, that's the speed. That is 2 meter per second. That means you have covered a distance on an average of 2 meter every second while you were running on the 100-meter track, right? So this is how speed is calculated. So students, we will have a look at the definition of speed. It's a very easy definition, right? Speed is the distance travelled by a body in unit time, and speed is given by distance travelled or total distance travelled divided by total time required to cover that distance. So with the help of an example, we will understand what is speed and we will take the topic ahead, right? So here students, we have speed. Speed is the distance travelled by a body in unit time. Unit time means 1 second or per second. That is speed. The second point to be written is speed is given by the formula total distance travelled, right, divided by the time required to cover this particular distance. Then the SI unit or standard international units of speed is meter per second, because here you will have speed is given by distance upon time. So the unit of speed should be the unit of distance, that is in meter, divided by the unit of time, that is second, and therefore the unit of speed is meter per second in the SI system. In CGS system, you have to replace the meter with centimeter, but very frequently, as I told you, they use the SI units normally to measure physical quantities. So the SI unit of speed is meter per second. CGS, I told you, is centimeter gram second system, right? And in that it will be measured in centimeter per second. As an example, I told you, supposing you are running a track event, right? You are running a race. So you are positioned over here at this point and this is the end point. They say on your mark, get set, ready, go, and you start running, right? You cover let us say you reach the finishing point in 15 seconds. So let us calculate your speed now. So the speed while you were running, the running race was, what is the total distance you have covered? 100 meter. What is the time? Let us say you have taken 50 seconds. So speed is equal to 2 meter per second. That means your average speed was around 2 meter per second. I hope students this will give you a very clear understanding of what is speed. So students, you have just seen now what is speed. Now students, tell me whether speed is a scalar quantity or a vector quantity. See, speed is measured in terms of distance covered upon time. Distance upon time is speed, and therefore speed is a scalar quantity, because to describe speed you do not have to describe direction. Only magnitude is important, numerical value is important. So therefore speed is a, magnitude means numerical value, right? Therefore speed is a scalar quantity. So now all of you know how you have to calculate speed. Speed is nothing but the distance traveled by a body in unit time, or speed is given by the formula speed equal to total distance traveled upon total time taken. And finally the third point is the SI unit of speed is meter per second. Students, whenever I ask you any definition, I need it to be written in points. Just as I had written on the board with speed, I first wrote the definition, then I wrote the formula, and last point I wrote the unit, right? Now students, having understood speed, let us look at velocity. Now velocity is defined as the distance covered or travelled by a body in a particular direction in unit time. Students, examine your textbook properly where the topic on velocity is, and read the words that I am right now defining. You will notice the difference between speed and velocity, right? Velocity says, velocity is defined as the distance traveled by a body in a particular direction in unit time. So now while talking about velocity, they are talking about distance covered in a particular direction, and a single word for distance covered in a particular direction means displacement, right? So the appropriate definition, or the proper and simple definition of velocity is the displacement undergone by a body in unit time is called velocity. So when I'm saying rate of change of displacement, that means I mean to say displacement divided by time. If I divide the total displacement undergone by a body by the total time taken by that body to undergo that displacement, then I will get displacement per unit time or displacement per second, right? So students, velocity means the rate of change of displacement. You use this definition. If I ask you what is velocity, you have to mention 3 points, right? What are the 3 points? The first point is the rate of change of displacement is called velocity. Second point, velocity equal to displacement divided by time. And what should be the unit of velocity? The unit of velocity should obviously be the unit of displacement divided by the unit of time. Unit of displacement is meter divided by the unit of time, that is second. So again, the unit of velocity is meter per second. If you look at the units of speed and velocity, they are same. meter per second, because both, one is measuring distance, the other is measuring displacement, and I told you units of distance and displacement are the same. So the units of speed and velocity are same, but the concept of speed and velocity is totally different. How? Because speed is total distance covered upon time, whereas velocity is total displacement divided by the time, right? Then speed is a scalar quantity because it does not need direction for its description, but velocity is a vector quantity because it needs direction, because it is involving displacement. So displacement involves direction, so velocity needs direction for its description, and therefore velocity is a vector quantity. Now students, I hope you have understood the difference between speed and velocity. I will take you to the board and we will talk or discuss a few more points about velocity before we conclude for this session, right? So here students, we have the definition of velocity. The distance traveled in a particular direction by an object in unit time is called velocity. Now if you notice these words here that I have underlined, distance traveled in a particular direction. For all these words, there is one word, distance traveled in a particular direction, right? Distance traveled in a particular direction can be called as displacement. So it is the displacement by an object in unit time is called velocity. That is why I have written the simplified definition here. Velocity is the displacement that occurs in unit time. Displacement is a single word for distance traveled in a particular direction, right? Instead of saying distance traveled in a particular direction, one word is enough, that is displacement, right? So if you are asked to define velocity, you can put it in 3 points. You can use the shorter form. The first point, instead of writing this, you can write this as the first point. Velocity is the displacement that occurs in unit time. That will be the first point. Second point, velocity equal to displacement upon time. And third is the SI unit of velocity is meter per second. If you want to write CGS also, you can write it here down, but CGS will be centimeter per second, just as we saw in speed. We will discuss a few more points related to velocity and speed. You have already seen the difference in the definition. Speed is talking about the distance covered in unit time, and velocity is talking about the displacement being covered in unit time, right? So I told you that speed is a scalar quantity since it is involving the distance covered in unit time, and to describe speed you do not require to specify direction. But velocity is a vector quantity because it is having the component of displacement, and displacement has direction. To specify or to describe displacement, you need direction. Therefore, students, please remember, in order to describe velocity, you require magnitude, that is numerical value, as well as direction, and therefore velocity is a vector quantity. Now students, when we were studying speed and distance, we came to one very important point, and that will help you to understand what I am saying. Now students, you just think logically. If distance and displacement are equal, right, and the time taken also is the same, then will speed be equal to velocity? Just think about it. I am putting the question to you again, right? If distance and displacement are equal, right, and the time taken to cover that distance and displacement is the same, then will speed be equal to velocity? Students, I just in my last lecture showed you, right, that when motion takes place along the straight line, I gave you an example in the last lecture, right? When motion is along a straight line, the value of distance and the value of displacement are the same. So that brings us to a very important point. If motion is along a straight line, then magnitude of speed, magnitude is numerical value, then magnitude of speed is the same as the magnitude of velocity, right? Please remember that very, very important point. If motion is along a straight line, the magnitude of speed will be equal to the magnitude of velocity. We can understand this with a simple example. We will take up that simple example, and that should make you or clarify the doubt in your mind. So we will take up that example on the board and we'll see what happens to speed and velocity if motion is along a straight line. We will also study what is the difference between speed and velocity when motion is not in a straight line. So come, let's have a look at it right now. So students, here we will have a difference. We'll see how speed and velocity, in which circumstances speed and velocity is the same, and under which circumstances speed and velocity are different, right? Now let us take an example. See, here motion is not in a straight line. So this is not a straight line motion, this is a straight line motion. So let's look at this case. We discussed this case in the previous lecture. You have a body moving from A to B covering 4 meters, right? And then from B to C covering 3 meters, right? So the initial position is A, final position is C. So distance is AB plus BC and displacement is AC, right? And AC is here 5 meters. This is 4 meters, this is 3 meters, this is 5 meters. This is the shortest distance between A and C. So now let us use the formula and calculate speed in this case and velocity also in this case. See, now here you can see speed is equal to distance upon time. So distance is 4 meter upon 3 meter, that is 7 meter. Let us assume that they cover both. If traveling from here and traveling from here, both, let us assume that it takes 10 seconds just for understanding purpose, right? Let us assume that this person has gone faster or slower, whatever, all these people have gone faster, it doesn't matter. Let us assume that the time taken to go along this route and this route is the same. Maybe one of them, if the person is going by this route, they will have to walk faster. This person will have to walk slower because the distance is less, right? So let us assume the time remaining the same. Now speed is distance upon time. So distance is this 4 plus 3, 7 upon the time taken is 10 seconds. So speed is 0.7 meter per second. Now let us look at velocity. Velocity is displacement upon time. I told you this is the displacement, the shortest distance between A and C. So 5 meter divided by 10 second is 0.5 meter per second. Now there is an interesting observation. You can see that when motion is not in a straight line, the magnitude of speed will be greater than the magnitude of velocity. 0.7 meter per second is definitely greater than 0.5 meter per second. So when motion is not in a straight line, you can see that the magnitude of speed, magnitude means numerical value of speed, is greater than the numerical value of velocity, right? Now let us look what happens to the scenario where motion is along a straight line. So the person is walking from A to B 4 meter in a straight line, thereafter continues in the straight line for another 3 meters. So B to C is 3 meters. So total distance covered is 4 meter plus 3 meter, that is how much? 7 meter. I told you that when motion is along a straight line, distance and displacement is the same, that is 7 meter. Can you see? Because anyway, A to C straight line is also the minimum distance, right? Therefore, this will be the displacement and this will also be the distance. So, using the formula of speed, distance upon time, so 7 meter upon 10 second, 0.7 meter per second. Velocity, displacement upon time, 7 upon 10, 0.7. So, a very important point you can understand over here, if motion is along a straight line, then the magnitude of speed is equal to the magnitude of velocity, right? Can you see over here 0.7 and 0.7 because motion is in a straight line. So when very important point you have to remember is when motion is in a straight line, the magnitude of speed and velocity is the same. So students, by now I believe you have understood the difference between speed and velocity, right? You have seen in the second case that because motion is in a straight line, the magnitude of speed and the magnitude of velocity is the same. Magnitude means numerical value, right? It's clear, and you've seen that when motion was not in a straight line, magnitude of speed is greater than the magnitude of velocity. Students, you can go through it. If you have any doubt in understanding this concept, you can call me back again should you have any doubt. Right, students? Now, students, we will discuss 3 ways in which velocity of a body can change. See, velocity of a body depends on the magnitude and direction, right? Because displacement is involved, so direction is involved. So, velocity of a body can be changed in 3 ways. One is the speed is constant, but the direction continuously goes on changing, right? Let us say a car is moving with 50 km/h per speed, constant speed, but it is keeping on turning its direction continuously. Then, because it is changing its direction continuously, obviously displacement is changing, and therefore what happens is that velocity changes. So if a body is keeping speed, so velocity can be changed by keeping speed constant and changing the direction. The second way in which velocity can be changed is keep direction constant and change the speed. 10 km/h, then next second 20 km/h. So you are increasing the speed. So either you are increasing or decreasing the speed and you are keeping the direction constant. Then also in this case velocity changes. So velocity can be changed by what? By changing the speed and keeping direction constant. And the third way in which velocity can be changed is by changing both. Changing the speed as well as changing the direction. Students, in your textbook there is some example mentioned on one of the page after the definition of velocity, right? So you can read those examples of a vehicle changing speed sometimes, changing direction sometimes, and changing both. You will understand the point that I am explaining to you right now. Now, I will repeat the 3 ways in which velocity of a body can be changed. The 3 ways in which velocity of a body can be changed are: keep the speed constant and change the direction. Second, keep the direction constant and change the speed. And third, change the speed as well as the direction. So students, with this I have now concluded my today's lecture on speed and velocity. I have discussed all the possible things which are mentioned in your textbook, right? If you have any doubts, please do not hesitate to call me and ask me personally, right? You can also send a personal WhatsApp to me in case you don't feel like calling or you are shy to call up. you can send a WhatsApp message. I will deal with your doubts, right? So students, till then, take care, stay safe. Thank you all of you, and bye for the day.